Okay, ladies and gentlemen, welcome to the second of four videos for Chapter 2, Section 8. This video has actually been added after the fact to these video notes, so it's being inserted between video 1 and video 2 of the previous three. This video is going to cover non-proof examples of using the angle properties, the angle theorems and postulates discussed in Chapter 2, Section 8 of your geometry book. So here on this first page we have two examples. We're going to go through them both. I'm going to write in red what your thought process should be setting up the problem, and then in blue I will show the actual work. Okay. So in this first problem we need to look at the picture, we need to make a decision. We need to recognize that these two angles, angle 13 and 14, those form a linear pair. And when we notice that, we should then go to our list of theorems and postulates and find the theorem that deals with linear pairs, that is the supplement theorem. The supplement theorem says that the measure of angle 13 plus the measure of angle 14 must be 180 degrees because it says that linear pairs are supplementary. So then what we do from there is we plug in these values from up above for 13 and 14 in our equation. So the measure of angle 13 is 4x plus 11. The measure of angle 14 is 3x plus 1. We plug those values in, and we're going to solve this equation to find x. Now we need x in order to plug back in and find the measures of angles 13 and 14. So we combine like terms. We've got two sets of like terms on the left side. 4x plus 3x is 7x. 11 plus 1 is 12, equals 180. Then we need to subtract 12 from each side of that equation, which would give us 7x equals 168. Then we would divide by 7. Which would give us x equals 24. Now, if x equals 24, we then need to take that x value and plug it back into the measure of angle 13 and the measure of angle 14. The measure of angle 13 was 4x plus 11, so that would be 4 times 24 plus 11. Well, that would be 96 plus 11, which would be 107 degrees for the measure of angle 13. And for the measure of angle 14, it is 3 times x plus 1, so 3 times 24 plus 1. That would be 72 plus 1, or 73 degrees for the measure of angle 14. Remember that these two angles should be supplementary, so when you get your answers you can check them by checking to see if 107 plus 73 is 180, which it is. In the second example here, we need to recognize that angle 2 and angle 3 are vertical angles, which means that according to the vertical angle theorem, they must be congruent. Okay, so we need to think to ourselves, okay, the vertical angle theorem says that angle 2 is congruent to angle 3, which means that the measure of angle 2 is equal to the measure of angle 3. And then we're going to solve the equation for them by plugging in the values from up above, just like we did in the previous example. So that would be 4x minus 26 for the measure of angle 2 equals 3x plus 4 for the measure of angle 3. There are no like terms in this equation, so we move to isolating the variable. We would start by subtracting 3x from each side, which would move the x to the left. While we're at it, we'll also add 26 to each side. That would give us that x equals 30. Once again, we're going to take that value, we're going to plug it back in to find the measure of the actual angles. So that would be 4x minus 26 for angle 2. That is 4 times 30 minus 26, which is 94 degrees. And for the measure of angle 3, that's 3x plus 4, or 3 times 30 plus 4, which is also 94 degrees. So the measure of angle 2 is 94 degrees, and the measure of angle 3 is also 94 degrees. Again, our answers should be the same because those angles are vertical. Okay, so that should be review from Chapter 1, Section 5. These two questions, however, should be new material. So these two questions are involving adjacent angles, which means that we should immediately in our head think angle addition postulate. Both of these examples are based on the angle addition postulate. So as soon as we see this kind of picture in our heads, we should immediately go to, oh, well, that's the angle addition postulate. Okay, that's what we're going to use in these problems. So in that picture, you should see, we're doing the one on the left first, you should see three angles. The big angle, FGH, which is made up of two smaller angles. Okay, so we need to come up with an equation here. Now, using the names from the problem, HGF is the big angle. It is made up of the two smaller angles. So if we add the two smaller angles together, which would be EGF and HGE, they would equal the bigger angle, HGF. So that's the equation we set up using the angle addition postulate. Now from there, we're doing the same thing we did on the previous page. We're plugging in these values that are given in the problem. So HGF, the measure of angle HGF is 16x plus 4. The measure of angle EGF is 110. And the measure of HGE is 3x plus 11. Once we plug those in, we're solving that equation for x. So we have 16x plus 4 equals 3x plus 121, because 110 and 11 get combined as like terms. We then subtract 3x from each side to isolate the x. While we're at it, we're also going to subtract 4 from each side. That will give us 13x equals 117. Divide by 13 on both sides, and we have that x equals 9. We go back to make sure that's what we were supposed to find. It does say in the problem to find x, so that problem is complete. On the second example, same idea. We have a big angle, angle ABC, which is made up of two smaller angles, angle ABK and angle KBC. So according to the angle addition postulate, the measure of the big angle, ABC, is equal to the sum of the two smaller angles. So the measure of angle ABK plus the measure of angle KBC. We're then going to plug in the values from the problem. So ABC is 17x plus 8. The measure of ABK is 42. And the measure of KBC is 12x minus 4. Once again, we solve for x, so we add like terms. 17x plus 8 equals 12x plus 38. Then we isolate the variable, subtract 12 from each side, and subtract 8 from each side to move the variable to the left, and the number to the right gives us 5x equals 30. Divide by 5, and we get x equals 6. Go back and check to see if that's the answer to the question. It is not. We are told to find the measure of angle ABC. So the measure of angle ABC can be found using x, because the measure of angle ABC according to the directions is 17 times x plus 8. So that is 17 times 6 plus 8, which means that the measure of angle ABC is 110 degrees. I think 42 plus 60, 102. Yep, 110 degrees. So our answer to the problem is 110 degrees. That does it for this video. This is again the non-proof video for these 2-8 examples. Thank you very much for your time.